Alright, so right over here, let us look at the volumes right now. Okay, so looking at the volumes, right? So when you want to find the volume, okay, so in that case, we have to integrate the area, right? So the first method that you're going to be using, that we're going to be introducing, is the disk method, okay? The disk method, right? So about the disk method, take it as like this, okay? So we have the curve, I guess, on the prescribed textbook. You will see the images. They will just give you the drawings images. Consider this curve right over here. So this is your y is equal to the square root of x, okay? So now the thing that we do right over here to find the volume, we just revolve this about the x-axis or the y-axis. So in this case, let's say you revolve this line about this curve about the x-axis. So when you revolve this, you will get something like this, okay? So you will get, this is going to be curve, and then you're going to get this one, right? And then you will have a solid, right? This is going to be a solid. Now the thing that we do, we divide this into infinitesimally small discs, right? So we just divide that, cut that into small discs, and then after that we integrate to add all those discs, okay? So which means right over here we only have one disc, okay? So in this one disc, the volume is going to be equal to an integral from a to b of the area the x dx, okay? The area of this circle, right? So in that case, the volume is going to be equal to, from a to b, what's the area of that circle? It's going to be pi r at x squared dx. The reason why I'm saying r at x is because I'm specifying, because right over here, this is going to be dx. So when you're working with y, you would say v. When you revolve this about the y-axis, you will say the volume is going to be equal to integral from a to b of pi r at y squared dy. This is what you're going to have, okay? So right over here, when we move on, this is what you will have, but on the other textbook, right? So look at this. The radius of this curve will start from this part all the way to the top. You see now that this is just your curve, right? So which means right over here in some other textbook they will say from a to b of pi of the function squared dx. They will do it like this, okay? I don't like it like this, but it's like that, okay? Because right over here, if we say the function, right now students got confused when you revolve this about a line maybe equal to -1, and then they got confused. But when you're working with the radius, you know that, okay, fine, I'm just looking at the radius, okay? So in that case, let's put the same thing. From a to b of pi, that's going to be f at y squared. That's your dy. This is what you're going to have, okay? So that is the volume. When you, with the volume equation, when you want to find the volume, you use these equations, right? And then let's look at the examples real quick. Okay, so let's just use this, right, as our example. Okay, so let's say right over here we've got the interval from 1 all the way to 4, right? So in that case, we got the interval. So the volume is going to be, this is going to be example number 1, right? So the volume is going to be equal to integral from 1 all the way to 4, right, of what? Of pi, okay, multiplied by the function, the curve. But now I don't want to work with the curve, I want to work with the radius. So the radius right over here, it is our function, our curve, right? So yeah, in this case we're just going to have to just put the curve equation, right, which is our square root of x, okay, squared, that's going to be a dx. Right, so in this case there is a y. I say square root of x because this is your y. When you go from this part to that part, this is just your y, okay? That is your y. So your y in that case is going to be equal to square root of x. So that is why I put the square root of x right here, okay? Squared dx. And then when we carry on, this will be pi because it's a constant from 1 to 4. And then these two would cancel out the root, and then we will have x dx. and then this is pretty clear. Okay, the volume is going to be equals to pi, and then we'll have x squared divided by 2 integrated from 1 to 4. This is what you're going to find. Okay, and then I don't like to finalize my answers because I'm doing MATH141, okay, which is something that you have to practice, you have to know before you do this module. But I'm just going to continue as a baby. Right, so in this case we're going to have this pi. It's just the multiplication right there. So this pi, and then after that we're going to start substituting the 4 right there. So we're going to have 4 squared divided by 2 minus, we're going to have, so right over here it's just 4, and then you're going to have 1 squared divided by 2. Okay, this is what you're going to have. So in that case the volume is going to be equals to pi outside, and then so 4 squared, that's going to be a 16 divided by 2 minus 1 over 2. Right, so the volume is going to be equals to, and then yeah, you'll have to do the math. So 16 divided by 2, there's going to be 8, right, minus your pi divided by 2, that's going to be divided by 1, and then in that case you will have to compute that. V is going to be equals to 2, and then 8 times 2, that's going to be 16 minus pi, so there's going to be 15 pi divided by 2. This is what you're going to have as your answer. Cheers.